All right, what's up, guys? This is question number 1 from the 2014 AB exam. In this question, we have grass clippings that have been placed in a bin, and A of T gives us the amount of grass clippings remaining in pounds. Okay, part A, it wants us to find the average rate of change of A of T between 0 and 30. So A of T is continuous and differentiable, so I can get my average rate of change by doing the slope of the endpoints. So A of 30 minus A of 0 over 30 minus 0 gives me negative 1.97. Since A of T is in pounds and I'm dividing by days, I have pounds per day. Part B, find the value of A prime of 15. Okay, so you just type in math 8, type in A of T, 15, hit enter, negative 1.64. It asked me to interpret the meaning of this. So since it's negative, that means that the amount of grass clippings in the bin is decreasing, and it's decreasing at a rate of 0.164 pounds per day. Part C. Find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin between 0 and 30. All right, so A of t is the amount of grass clippings in the bin, and I'm setting that guy equal to the average value of the amount of grass clippings in the bin. All right, that's 1 over B minus A. Okay, so I've set those guys equal to each other. What I'm going to do is go to my graph, or go to y equals, and I'm going to type in whatever A of t is, the 6.687 stuff, minus, and I'm going to type the math over to frac to get my fraction. I'm going to type in math 9. I'm going to type it in just like you see it here, and then I'm going to graph it. Now your graph is going to take a really long time. So remember, from your window screen, you can change your X res to 2. And that'll speed your graph up and still give you the right answer, okay? So once you've graphed it, you'll see that this guy's crossing the x-axis at 12.415. Part D, when t is greater than 30, L of t, the linear approximation at A at t of 30 is a better model. Use this L of t to predict the time when there will be a half a pound of grass remaining in the bin. Okay, so we're making a line, which means we got to have a point in the slope, and it tells us that the t value is 30. So I got 30 comma something, okay? Well, the tangent line, it picks up on the graph of A. So like the 30 comma whatever is shared by both A of t and L of t. So I can plug 30 into the A of t equation and I get 0.782, all right? A prime of 30 is negative 0.056. All right, so I've got my point and my slope. When I write my line over here, they've called it L of t, so I've labeled my points as t and L of t. All right, so y minus y1 equals m times x minus x1. I just added 0.782 to both sides. Didn't really feel like dealing with the decimals, so I just left it. Okay, so this right here is now what I'm using to figure out the time there's a half a pound of grass left. So I set that guy equal to 0.5. Okay, I decided to subtract 0.5 from both sides. That's how he turned into a 0.282. And then I graphed this, and I saw that this one crossed the x-axis at 35.054. Now, when you look at my work solutions, you'll see that I have more decimal places in here. And it's because I didn't use those rounded decimals when I actually did my work. You don't want to round until the very end. So you're going to want to carry like 4 or 5 or 6 decimal places along as you work the problem and then round at the end. All right.